here? Should I turn this on? Testing? All right, cool, we're on. Hello, everyone. Just getting my computer set up. There we go. Can everybody see? Awesome. So my name is Sara Robinson, and today I'm going to tell you all about how we can do text analysis using machine learning, going from a pre-trained API where you can access a machine learning model with a single REST API request to building a custom model with your own data. So I'm a developer advocate on the Google Cloud Platform team. I'm based in New York, and this is my first time in Estonia. I just landed a couple hours ago. Still a little jet lagged, but I was in London before, so I've had a couple days. So as a developer advocate, my job is to teach external developers like all of you how to use different tools on Google Cloud Platform, and I focus on machine learning. So day to day, that involves a combination of building demos, writing code to show people what you can do with these products, giving talks at events like this, and then also writing online content like blog posts and videos. And an important part of our job is to bring feedback from the community back to the engineers who are building the product. So if any of you have used any of Google Cloud's specifically machine learning products and have feedback, things you really liked, things you didn't like, let me know and I can share that with the product team. And you can find me on Twitter at @srobtweets. I share almost all of my code and blog posts on there. So let's get started by talking about what is machine learning. So at a high level, machine learning involves teaching computers to recognize patterns in the same way that our brains do. So for us as humans, it's really easy for us to identify the difference between, let's say, a cat or a dog, because we've had billions of years of evolutionary experience to help us with that. To a machine, that's a much more difficult task. So machine learning involves building models that improve as they're given more examples and experience, and that they can slowly learn to generalize on examples that they haven't seen before. So if anyone remembers how you learned your first language, your first spoken language, not programming language. So your parents probably didn't give you a dictionary and a bunch of grammar books to memorize. That'd be kind of weird. Instead, you learned over time by being exposed to many different examples. So let's say you had pasta for dinner. You saw the pasta on your plate, heard your parents identify it. Maybe you identified it incorrectly a couple times and were corrected. Over time, this strengthens certain pathways in your brain. And this is roughly how machine learning works as well. So today I'm going to focus on what's called supervised learning. So this is the problems where we give our models labeled input when we train it. And we can think of almost any supervised learning problem in this way. We give our model labeled input. Then our model has some algorithms that results in a prediction. Now the amount we know about how that model works under the hood is up to us and the tool we use to solve the problem and the specific type of problem that we're trying to solve. So that was a high-level explanation, but how do we actually get from input to prediction? Now I'm going to be talking about text, so natural language processing in this talk, but input could be many different things other than text. It could be the pixels in an image, it could be the audio if you're trying to do speech recognition. It could be many different types of unstructured data. In this talk I'm focusing on text. If you are coming to geek out, I'm going to talk a little bit more about, I'm going to talk about text, but also about some image classification. So one example is, let's say we have the headline of this article from the New York Times, and we want to build a model that predicts that this is an article about sports. Or let's say we want to build a model that's able to tell that this is an article about baseball, a little bit more specific. Or let's say we want to do something custom, and we want to build a model that's able to predict that this headline came from the New York Times. Another example of what our inputs could be is, let's say we've got a bunch of Stack Overflow posts, and we want to predict the tag of these posts. So as I mentioned before, the tool you use depends on the type of machine learning problem you're solving, and I like to think of this along a spectrum. So on the left-hand side we have generic tasks, on the right-hand side we have more custom tasks. So if we're solving a generic task, someone else has already solved this before, we probably don't need to start from scratch. So we'll take this text from one of my tweets as an example. Let's say that I want to extract parts of speech from that. I want to know if it's a verb, a noun, or a pronoun for the different tokens in the sentence. This is a pretty common natural language processing task, so I don't need to start from scratch. I could if I wanted to, but I might as well make use of many of the pre-trained models out there that are great at doing exactly this. But let's say I've got a custom task that's specific to my data set. So let's take the same text, but instead of extracting parts of speech, let's say that I want my model to predict that this is a tweet about programming, and more specifically, it's a tweet about Google Cloud. Now, to get these predictions out of my model, I'm going to need to give it thousands or hundreds of thousands of tweets about these different topics that I want it to extract. Because remember that the output of your model, the accuracy and quality of your model, is only going to be as good as the training data that you give it. So in this talk, I'm going to talk about how we can go from API to custom model. Since I work on Google Cloud, I'm going to be talking about our Cloud Natural Language API. There's many different APIs out there for doing natural language processing, so I encourage you to try out a bunch, see which one is best for you. And then I'm going to be talking about building a custom model with TensorFlow, which is Google's open source framework for building and training your own machine learning models. I'll get into that a bit later on. So I'll start with the API. So Cloud Natural Language is an API that lets you understand text. So you pass it text and you get a bunch of different types of analysis back. And all of the different things it can do are detailed on this slide. So the first thing it can do is it can extract key entities from text. It can also detect sentiment. It can tell us whether text is positive or negative. It can get a little bit more into the linguistic details of text. So if I wanted to do what I was talking about before, extracting parts of speech, I could do that with the analyze syntax method. And then the newest feature of this API is content classification. So you can classify your text in a bunch of different, into a bunch of different content categories. Now the great thing about using this API is as an application developer, you can access these pre-trained machine learning models without really needing to know anything about how that model works under the hood or anything about machine learning. So you can just pass it some text, get some data back. It's just a REST API, so you can access it in any language that you'd like. So it's a great way to get started with machine learning. We've got a bunch of different APIs for not just text classification, but we have image analysis, speech to text, video analysis. So if you're new to machine learning and want to get started, definitely recommend trying out an API that gives you access to a pre-trained model. Really good way to get started with machine learning. So going into a little bit more detail on what these different methods provide, the analyze syntax method gives us a lot of linguistic details on the text. So if we take this sentence as an example, the Natural Language API helps us understand text. This is just a visualization of all the different data we get back from the analyze syntax method. So we get the part of speech, that's what's in red. We get the role of each word in the sentence, that's the parse label in orange. So for example, API is the nominal subject, helps is the root verb. And then those arrows in green are what's called a dependency parse tree. So this tells us which words in the sentence relate to other words, which words depend on other words. Then we have the lemma. You can see here we only have one for help. So the lemma is the canonical form of the word. So for helps, the lemma would be help. And this is useful if you've got any situation where you want to count how many times a certain word was used to describe something in your application. You probably don't want to count helps and help as two separate words. You just want to use the canonical form. So then you would use the lemma. And then finally in the bottom row we get some additional morphology details on the text. And this is going to vary based on the language that you send your text to the API in. It supports a couple different languages. Unfortunately, I don't think it supports Estonian yet, but if you've got use cases for it, let me know and I can pass that along to the team. So the next method I want to talk about is content classification. So what I did here is I took the headline and the first sentence of this article from the New York Times. I sent it to the content classification endpoint. And it gives us back, in this case, just one category. So it's able to tell us that not only is this an article about sports, but more specifically, it's an article about baseball. And what's cool is the word baseball isn't actually mentioned anywhere in this text. But the API is 99% confident that it's an article about baseball. So you can get multiple categories back. In this case, we have just one. So here is some example code of calling the natural language API from Node. I do a lot of my demos in Node.js, but obviously you can call the API in any language that you'd like. We have a number of different client libraries for popular languages. So this is an example in Node. We're using the Google Cloud Node module, and then we're creating a reference to the language object. And then in this case, we're passing it the URL of a text file in Google Cloud Storage. You can also just pass it the raw text that you want to send to the API. And then here we're calling the annotate method, and then we'll get our analyzed text data back in that API response. So I don't like to get too far into a talk without showing a demo. So I'm going to show you a demo of our natural language API here. So what we have here is the natural language API products page. And on the product pages for all of our different APIs, you can try them directly in the browser. So there's an example sentence here. We'll analyze it. And we can see that here we get all of the different entities. So this is the entity extraction method. It tells us the sentiment of them, and it links us to the Wikipedia page for those entities if there is one. Sentiment analysis, I'm going to show you a different example of that. This one doesn't have too strong of sentiment, so I'll get back to that in a moment. Syntax, we can see that we create here a dependency parse tree that is very similar to the visualization that I had on the slide. And then this is our content classification endpoint. So it's able to categorize this, and I believe there's over 700 different categories available. So really useful if you're doing something like if you want to categorize different articles or maybe comments or reviews in your application. You can use the content classification endpoint. What?
Do you mind if we ask questions like on the go, or you prefer questions like in the end of the session?
Would prefer at the end, if that's cool. Yeah? Okay. Yes, I'll answer all your questions at the end. So if we try another sentence in here, I'm going to say, Tallinn is beautiful, but the weather is not great. Let's see what it says about that. So here we can see that we actually get entity level sentiment analysis. So in our sentiment data, we get this score value, which is a number. Let me make this a little bit bigger so you can all see. It's a number ranging from -1 to 1, telling us how positive or negative this specific entity is. So we can see Tallinn got a score of 0.7, almost fully positive. Weather got a score of -0.7. Weather's not great today. I heard I missed some really good weather, but I'm here for a couple days, so hopefully it'll improve. And magnitude just tells us how strong the sentiment is, regardless of being positive or negative. So this is a value ranging from 0 to infinity. So you can see here how this would be useful if you're doing any sort of review or comment analysis, where the aggregate sentiment score, which we get here for the entire document, isn't going to be so useful to us because it tells us 0 here, but actually it had quite a lot of sentiment in it. So that's where you would want to use the entity level sentiment. The content categorization feature is right now only supported in English, but what you can do is use the translation API, another machine learning API we had, translate your text to English and then run content classification on it. So that is the natural language API. So when I present on any of our APIs, I often get the question, what if you need something more custom? So the API provides a lot of useful types of data, but there's a lot of situations where you might need a custom model that's trained on your own data. So the next part, I want to talk about custom text classification with TensorFlow. To start, what is TensorFlow? Has anyone here used TensorFlow? Cool, looks like about 5 or 10 folks. So TensorFlow is an open source project, and from the beginning, the Google Brain team wanted everyone in the industry to be able to benefit from all of the machine learning projects that they were working on. So they made TensorFlow an open source project on GitHub. It's the same code base that we use internally at Google. And because TensorFlow is open source, you can train and serve your TensorFlow models anywhere. So you can run your training jobs on your own servers and your own data centers. You can run them on VMs and cloud providers. You can even compile your TensorFlow models down to ARM code and serve them directly on mobile devices. The uptake of TensorFlow since it launched, I believe at the end of 2015, has been really phenomenal. It's the most popular machine learning project on GitHub. I believe it has, I think it just crossed over 100,000 GitHub stars. So what does TensorFlow look like? I'm going to show you a diagram of what the API looks like starting from the lowest level. So at the lowest layer here we have the op kernels, the CPU, GPU, TPU's mobile device. And to execute these kernels, we have the TensorFlow distributed execution engine. What most developers are going to interact with is the API front ends. And I'm going to focus on the Python front end today. So when you're using TensorFlow, you can choose whether you want to use a lower level or a higher level API. With the lower level API, you have more control over writing the algorithms that are going to be used behind your model, defining the different operations in your TensorFlow graph. The higher level APIs abstract a lot of that for you, so you just need to know what type of model you want to choose, and TensorFlow handles the internals of that for you. So one of the higher level APIs is called Keras. So Keras is an open source project created by someone named Francois Chollet, who now works at Google. And TensorFlow contains an entire implementation of the Keras API as part of TensorFlow core. And both of the demos that I'm going to show today use the Keras API. It's really easy to use syntax for defining the different layers of your model. So it lets you build models with high-level primitives. Has anyone here used Keras? Curious. Looks like just a couple. So you can use Keras on its own, or you can use tf.keras to get access to some of the utilities that TensorFlow provides, like the TensorFlow estimator. So TensorFlow estimators let you give you access to distributed training. So you can run your TensorFlow training job across clusters of machines without having to change any of the code in your model. You also get access to a tool called Tensorboard, which is a visualization tool for evaluating your model as it's training. And then you can easily export your model for serving. So with estimators, you instantiate your estimator, you define the machine learning algorithms and the type of model you'll be using, and you're ready to go. TensorFlow the estimator API takes care of distributed training and exporting your model for serving for you. And then finally, we have what are called pre-made estimators. These are models in a box. So basically, you just instantiate one and you're ready to go. You need to choose what type of model you want to use, whether you're solving a classification problem or a regression problem. You instantiate that type of model. You're ready to go. All you need to do is format your data get it into a format that TensorFlow can read, feed that into your model, and then handle generating predictions. So that's kind of an introduction to the TensorFlow API. I'm going to be focusing on Keras. So the first demo I want to show is building a text classification model using the Keras API. So the input to our model is going to be Stack Overflow posts, just the title, and our model should output the corresponding tag. I know many Stack Overflow questions have more than one tag. To keep things simple, we'll just use one tag as the prediction for this model. So the first step is to get our training data. So when we're building a model from scratch, we need lots and lots of data to get started. So I needed a large data set for this to work. I couldn't just pass it like 10 Stack Overflow questions and expect it to be able to predict the tag. So I'm using a data set from BigQuery. For those of you that aren't familiar with BigQuery, BigQuery is our big data warehouse tool on Google Cloud Platform. It lets you do data analytics, run SQL queries against really large data sets, and does it super fast. As part of BigQuery, they have something called the Public Datasets Program, where they've made a bunch of different data sets publicly available. Anybody can go use and run queries against them using the BigQuery API. And so one of those data sets is every Stack Overflow question and answer in BigQuery. So I took a subset of those and used them as training data for the model. So this is what the input to our model looks like, and this is what the prediction looks like. Now obviously we can't feed text directly into our model. We need to get it into a format that our model can understand, which is what I'm going to talk about in a moment. But first, we needed to get the training data from BigQuery. So you write your BigQuery queries in SQL. It also has, you can write them directly in the browser. There's also a BigQuery REST API, so you can run queries in whichever language you'd like. So this is the query that I used to extract my training data for this. So for this I chose to use 20 different tags. I just looked at the top tags page, grabbed the first 20, and I took 2,000 posts from each tag. So this is the query I ran to grab that, and then I split my data into training and testing data. So when you're building a custom model, you want to use most of your data to train the model, but then you want to reserve a subset of that to test your model to see how it performed on data that it has never seen before. So for this example, we're going to use what's called a bag of words representation to represent text into our model. Because remember that we can't feed that text directly into our model. We need to get it into a numerical format that our model will understand. So bag of words is a simple type of text representation that we can use to represent each question in our model. Now how this works is you can think of each input to our model as a bag of Scrabble tiles, where instead of a letter on each tile, it's going to be a word from a particular Stack Overflow question on each tile. So what this type of model takes into account is the presence or absence of different words in a question. What it doesn't take into account is the order of words. Obviously, if it's in a bag, it's all scrambled. Which words depend on other words, or the relationship between different words in your model. And what you want to do when you're building this is you don't want to include every word in your vocabulary. So I didn't take all my Stack Overflow questions and build a vocabulary of every word that exists there. You want to take just a subset of those. So for example, I could take the top 1,000 words from my vocabulary, and then each input to my model would be a 1,000 element vector indicating whether the particular question contained one of the words from my vocabulary. So I'm going to show you what that looks like on slides using a very simple example. So I'm going to say that I have a vocabulary of just 10 words, the 10 words listed here, and I've only got 3 possible labels that it could be. I'm just going to use this to keep things simple so that you can understand how bag of words works under the hood. So I've got 10 possible words in my vocabulary and 3 labels. And so let's take this Stack Overflow question as an example, how to redirect to another web page. Now looking at our vocabulary, oops, not going to skip ahead quite yet. Looking at our vocabulary, we can see that 2 of these words are present in our vocabulary, so redirect and web page. The input to this model for this particular question would be a 10 element vector. So every input to our model is going to be the same length. It's going to be the length of our vocabulary. So we have a 10 element vector that should have 2 ones indicating the presence of the words redirect and web page and corresponding with their particular indices in our vocabulary index. So that's how we'd represent this question to input to our model. And then this is how we will represent the prediction. So the prediction will be a one-hot vector indicating, so since in this example we only have 3 possible labels, it'll just be a 3-element one-hot vector indicating the correct label. So this is a question about JavaScript. So we can see here what the input and what the prediction looks like. The prediction is what's called a softmax vector. When our model outputs a prediction on data it hasn't seen before, it'll output this softmax vector, which just means that each of the all the elements in the vector will add up to 1, and they'll indicate the probability that this corresponds with that particular tag. Obviously, with our labeled training data, we already know what tag it is, so it's going to be a one-hot vector. But if we look at an actual prediction, it might look something more like this. So it's 95% sure that this is about JavaScript, 3% sure it's Java, 2% SQL. So they all add up to 100. Here's an example for a question about SQL. So if the title of the question is join 2 tables, the only word here from our vocabulary is join. And here our model is 92% sure that it's about SQL. So now let's look at the code for building our model using Keras. Keras has 2 different APIs that you can use to build the model. In this example, I'm going to show you the Sequential API. So the Sequential Model API is the simplest to get started with, and it lets you build your model as a stack of layers. So here I define my model as a sequential model. in my first layer, this is a dense layer, which basically just means it's fully connected. Each neuron in one layer is connected to every neuron in the next layer. And there's 512 neurons in this layer. This number is a hyperparameter that you can tune. So there's no like magic answer for what's the best number of neurons in a layer. You kind of just have to experiment with different values and see what works best for your data set. So when we define our layer, we tell it the input shape. So this is going to be the size of our vocabulary. In this simple example, it's just 10, so we have that 10 element vector. This model just has 2 layers. So the activation function just tells Keras what the output of our model will look like. What type of calculation is it going to use to perform the output? So the output of this model is going to be the number of classes. In this case, we just have 3 tags in this example. And as I explained before, it's what's called a softmax vector, which just means that it's going to give us the probability that this prediction corresponds with each of our different tags. So to build our model is just these 3 lines of code, and the 4th to compile it. So which is pretty amazing. So we don't have to really know much about how these algorithms work under the hood, what these activation functions are actually doing. We can just define our code simply with these 3 lines. And then in this compile step, we have here what's called our loss function or error function. And this is how our model is going to evaluate how it performed at the specific task. The goal of our model is, as it's training, we want to minimize this loss. We want to minimize that error. We don't need to worry too much about the loss. The optimizer is going to tell our model how it's going to minimize the loss. Keras and TensorFlow come with a whole different bag of different loss functions and optimizers. But the great thing about using these higher level APIs is that we don't really need to focus on how those work under the hood. We can focus on getting high quality training data for our model, figuring out what type of model we want to use, in this case bag of words, and then using our model's loss function to evaluate how it performed. So this is how we train our model. We just call model.fit. We pass it our training data. So this will be our bag of, xtrain would be our bag of words, and then the ytrain would be the corresponding labels. Batch size tells our model how many elements it's going to evaluate at one time. Again, this is another hyperparameter that you can experiment with. And then epochs is how many times our model is going to go through our entire training set. So every time it goes through the data once, it'll then look at the loss function, update the weights of the model, and then iterate through that training data again. This is another thing that you can tune. So obviously, you don't want to train it forever. At a certain point, it's going to stop improving accuracy. So you kind of want to see how it's doing. This is going to be very specific to your data set again. And then to evaluate how our model performed, we call model.evaluate. And that's going to give us our accuracy score back. So let's see this in action. I'm going to jump back to the browser. And I'm going to use a tool here called Collab. So Collab is, I'm going to connect to the runtime. Collab is a tool that lets us run Python notebooks in the browser. It's hosted on Google Cloud. So I can write interactive Python code, run it in the browser. I'll have a link to Collab at the end. It's just collab.research.google.com. You can go to it and spin up your own notebook right now if you'd like. And it gives you access to a free GPU. Let me make the font size a little bit bigger. Okay. So this model trains pretty quickly. So I'm going to run through the code that actually trains the model, and then we'll evaluate its accuracy on some sample input. So this is not authored by Google. It was authored by me. I'm going to run it anyway and take a risk. Okay, so in the first 2 cells, we're just importing all of the libraries that we're going to use in this. We're using the TensorFlow implementation of Keras, and it was tested with TensorFlow 1.8. So the next thing we want to do is we want to download our training data to this Collab instance. So I have run this query, which I have a link to, and I'll share a link to this Collab at the end. So I have a link to the query in here, and I have saved all of the results of that query to a CSV file that's hosted on Google Cloud Storage. So I'm going to download that file to this Collab instance. There it goes. It's downloaded. And I'm using pandas here, which is a Python library for doing data analytics, data science. So I want to convert this to a pandas data frame, which I've done here. So I've done pd.readcsv. That converts this to a pandas object, which I can use to run some handy methods like just show me what the first 5 rows of my data look like. So this is what our CSV file looks like. We've got our posts and our tags, just like we saw on the slide. And let's take a look at how many of each tag we have, just to confirm that this is the data that we're expecting. So again, these are the 20 different tags we're using, and we do have 2,000 of each tag. The next step, as I mentioned, is really important to split our data. A common training test split is 80% of your data used for training, 20% reserved for testing. So that's the split we're going to use here. So we're just going to define these variables, train and test size, train size to see, to extract our data. And then we're going to split our data frame into training and test data for our features and our labels. So now we're getting into the bag of words implementation. So as I mentioned before, we don't want to use our entire vocabulary when we define our bag of words. That's going to take a long time to train. There's probably maybe, I don't know, 50 to 100,000 different words in our entire vocabulary because we've got 40,000 different Stack Overflow questions. So what we want to do here is I chose 1,000. So I'm going to take the top 1,000 words from my vocabulary. This is a number you can experiment with. I tried a few, and this ended up having the best accuracy. And luckily, I don't have to extract those words on my own. Keras has some utilities for pre-processing text. So it has this tokenizer object. Is that noise coming from the building? Or okay, I didn't know if I was making that noise. All right, we're good. So it has this tokenizer method that we can use to create a tokenizer, and what that's going to do is it's going to give us access to some utility methods. So first, when we create this tokenizer, it is we're passing it the number of words in our vocabulary. So it's going to create this index for us, basically of the top 1,000 words. Each word is going to be associated with a specific index or number. So we're going to create our tokenizer, and then we are going to fit the tokenizer only on our training data. And then we can use this method text to matrix to then convert our text input into that bag of words representation. And then we're using a utility from the scikit-learn library to encode our label data. So here we're just converting all of our labels into a 20-element one-hot vector since we have 20 different tags. So here we create the encoder. And then we convert our labels in that step. So then in this cell, we're just going to take a look at the different shapes of our training and test data. So here, remember that our training data, we have 32,000 posts in our training data, and each of those posts is represented as a 1,000-element vector because that's the size we chose for our vocabulary. It's just a vector of ones and zeros telling us if words from our vocabulary are present in that specific question. And then our test data is all 20-element vectors because we have 20 different Stack Overflow tags in this specific problem. In this example, I am using a batch size of 32, and I'm going to run training for 2 epochs. And this is all of the code that I'm using to build my model. And here's where I'll train it. This should train pretty fast. Otherwise, I wouldn't make you wait here while our model trains. So I'm only running this training for 2 epochs. So the emphasis here isn't on accuracy. I just wanted to show you how simple it was to build a model with the Keras API. And looks like training is almost done. So now we want to evaluate how our model performed using our test data, so data it hasn't seen before. So we can see here that the accuracy is 80%, which is decent. Again, I mentioned the emphasis here wasn't on accuracy. And the number this is the number we want to pay attention to in terms of accuracy, because this is evaluating it on our test data set, data that our model has not seen before. So the next thing we want to do is let's take a look at how our model performed on some raw data. So in this case, I'm just going to take data from our test set, and I want to log how it performed on just a couple of different questions. So to generate predictions for my model, all I'm doing here is I call model.predict. Right now I'm just looping through the first 10 questions in my test data set, and I'm printing the label that the model came up with versus the actual label. I didn't print the entire question for all of these because some of them were pretty long. We can see that overall it did pretty well. This one, .NET, confused it for ASP.NET, pretty close. .NET and C# got confused there. So accuracy probably would be slightly higher if I only picked, .NET and didn't use the C# tag in my data set. But that's something I can look at. I can look at how it performed and then go back and decide how I want to fine-tune my data set there. So the next thing that I want to show you is what's called a confusion matrix. I'm not going to focus on the code for generating it too much. We don't have a ton of time, but I do want to show you what this plot looks like. Let me make that a little bit smaller. So if it looks confusing, it's called a confusion matrix, but it's actually not super confusing. We'll take a look. So what you want to see in a confusion matrix, and it's a little hard to see here because we have 20 different labels we're dealing with, but what you want to see is a strong diagonal from the top left. So what this is telling us is for our test data set, what percentage of each specific label did our model predict correctly? So the numbers are a little hard to see here, but the most accurate ones are the darkest blue. So it looks like for Android, it predicted 90% of those correctly. AngularJS, it got 98% of them right. Some of the ones it didn't do so well as were C#. Confused some of those for whatever that tag is. Let's see, .NET, which makes sense. So the confusion matrix is a really good way to see where there may be inconsistencies in your training data, where you may want to go back and fix your examples to make sure that they cover all the potential things you might see when you're generating predictions. So that is what the confusion matrix looks like. So let me see how much time we have. Looks like we have a bit of time.
10, 15 minutes.
15 minutes? Okay, cool. So I do have one more demo that I was going to show. I had a little more time today than I thought, so I added this one at the end. So what about a little bit more complex text analysis model? That's weird. The headline for this slide is not showing up, but hold on. So we're going to see, given a wine's description and variety, can we predict the price of the wine? Oh, there it goes. So this is what the example input and prediction to our model look like. So we're going to take the description, the variety, in this case it's a Pinot Noir, and our model will output what it thinks the price is. Now the reason this is well suited for machine learning is that we can't create explicit rules. So we can't say, like, every time the word vanilla is in a description and it's a Pinot Noir, it's a mid-price wine, whereas every time we see the word fruity, it's going to be cheaper. We can't make any rules like that. So I wanted to see if I could build a model that would be able to extract insights from this data. First step, again, since we have a custom model, we're going to need lots and lots of data to train it. So I used a tool called Kaggle to get the data. Kaggle is a data science platform. It's part of Google, and they've got a ton of great data sets on there. I definitely recommend checking it out. If you're new to machine learning and you're looking for interesting data sets to get started with, they have tons of awesome ones on there. So I found this data set that contains 150,000 different wines. It has a bunch of data on each one. It's got the description, the region it came from, the points rating, the price, different specificity by region, lots of different data. For this model, I just took the description, the variety, and the price. So I'm also going to use Keras to build this model. For this example, I'm going to build a wide and deep model. That's basically just a fancy way of saying I'm going to represent my inputs in two different ways. So I'm going to represent my inputs in both a wide and a deep representation. The wide representation is going to be exactly what we saw in the previous example. That's going to be a bag of words vector, so a very wide vector depending on what I choose as my vocabulary size. A deep vector, I'm going to use what's called embeddings. And embeddings, there's lots of blog posts out there about embeddings, so I'm not going to get too much into the details. But embeddings are a way to represent text in vector space, so that words that are similar to each other are closer together in vector space. So we use dense, like deep vectors to represent our text as embeddings. So we're going to represent them two different ways. And for this example, I used, it's a little hard to see, but I'll show you the code in Collab in a minute. So I'm going to use what's called the Keras functional API. So in our last example, we used the Sequential API. This one we're using the functional API. This gives us a little bit more flexibility for combining models and building models with multiple inputs. So the first step is to build my wide model. So in this case, I am representing the text as a bag of words. And then to represent my variety in the wide model is pretty simple. It's just going to be, I've got 40 different varieties in this data set. So in this example, I used, going back to the bag of words, I used a 12,000 as my vocabulary size. So each input is going to be a 12,000 element vector with my bag of words. For the variety, it's just a 40 element one-hot vector with each index corresponding to a different variety. Then I'm going to concatenate these layers, and my output is just going to be a numerical price prediction. So that's my wide model. And then to build my deep model, as I mentioned, I'm going to use what's called embeddings. And I can't feed text directly into my model, obviously, as we talked about before. I'm going to need to convert it to numerical representation for my embeddings. And the way that I do this is I represent each word as a different index. And so all my input still needs to be the same length. Not all the descriptions are the same length. So what I do here is I specify my input length as 170 because none of my descriptions are longer than 170 words. And then if we have shorter descriptions, we just pad it with zeros at the end. And then I choose, I tell Keras what the dimensionality of my embedding space is going to be. Here I'm using an 8-dimensional embedding space. Obviously, you can experiment with different numbers here and see what works best for the particular type of data you're dealing with. So this is what the input will look like. So we have a 170 element encoded vector with each integer corresponding with a different word in that particular wine description. I don't have my varieties here. I'm just representing the text in my deep model. So then using the Keras functional API, it's pretty straightforward to combine the outputs for these two models. So I get the output from my wide model, the output from my deep model. I combine that into one, and then I compile my model so that it's ready to use. I didn't include the code here for training, but it's the same as what you saw before, so I would just run fit and evaluate. So I'm going to jump to one more demo. Should be pretty fast. I think I have time for it. I've got another demo with Collab here. I'm going to make this a little bit bigger. So what I'm going to do here, this model took a little bit longer to train, so I'm not going to show you the training. What I'm going to show you is generating predictions on some raw wine description data. So I'm going to reconnect to the runtime, and the import cells look pretty similar to before. And what I've done here is I saved my model, which is a binary file, to a file in Google Cloud Storage. And Keras has this method load model, which lets me load a model that's already been trained so that I can run predictions on it. The tokenizer, which we saw when I trained my model, so that is not saved to the model binary. So I've saved it to a different file. Same with the variety encoder for the different wine varieties. I've saved that to a different file, and I'm also going to load that for when I generate predictions on my model. So like any good developer, we will ignore this warning and go on to the next step. All right, so then we're going to make some predictions on raw data. So what we have here is we have 5 different wine descriptions. So the description here corresponds with this variety Pinot Noir, which corresponds with this actual price. So we're going to see, I'll make that even bigger. We're going to see how our model performs on these 5 wines. First step is I wanted to just show you a visualization of what that tokenizer word index actually looks like. So this is a sample of it. So each word here corresponds with a different index. And then our variety encoder is just this 40 element vector with each variety corresponding with a different index. So first we're going to build the features for our wide model. Oops. Did I not run this? Let's see. Maybe I missed a cell somewhere in here. Alright, live demos. You never know how they're going to go. I'm going to reload this file. So it's pulling from another cool thing you can do with Collab is you can pull from GitHub. Oh, this already includes the output. Okay. Let me make this a little bit smaller. And I'm going to clear the outputs, and let's try this one more time. Alright, we're going to run it anyway. May have been in a weird state. So yeah, it pulled from this file on GitHub, which you can do. You can just create a URL that pulls from any notebook file on GitHub and create a Collab notebook for it. There we go. I must have just forgot to run that cell before. I think that was the problem. Alright, so we're back to where we were. This is a visualization of what the wide input to our model looks like. So we have our bag of words matrix. It's a 12,000 element matrix. I'm obviously not going to print it all here. And then this is for our first wine. So then the variety matrix is a 40 element vector. One hot vector with a 1 here, which corresponds with Pinot Noir, which is right here, which looks about right. And then we're going to create our deep representation, which is this vector that we're going to feed into our embedding layers. And here we have a pretty short description, so we've padded a lot of zeros onto it. That's just for our first description. Now that our input data is formatted correctly, all we need to do is call model.predict to generate our predictions. And in this step, I am just looping through those predictions and displaying what our model predicted with the actual price of the wine. So we can see that it did a pretty good job. This one predicted $46.4. It was actually $48. This one, it was about $30 off, but it was still able to extract that this was a more expensive wine. And we can see that it was pretty close for the rest of these sample wines as well. If you've got any you want to try it on later, we can take a picture of the description or just copy it into this notebook and try it out, see how it performs. So that is that demo. And that's all I've got. Here's some links to all the things that I discussed. If you want to take a picture of that, I'll leave it up for a moment. I've got blog posts corresponding with both of the demos, and the code for both of them is on GitHub if you want to run similar models on your own data. I don't know how much time we have for questions, but if we don't have enough time now, I can definitely take them after.
We have some, so let's start with a quick question and answer session. Any questions?
Yeah, any questions?
Yes. Good talk.
Thank you for a good talk. You actually showed how to build a model, right? But business wants two things. Not only to build a model, but to show that it's the most optimal model, and to show that it's very easy to interpret this model. How can I use this functionality to move in these two directions, actually? What can you propose?
So are you asking about like serving the model in production and then building something that generates predictions on it?
Actually, how to prove that this model which I can build here is the most optimal, the best ones among all the others which I can build? With other technologies, right? And why it is easy to interpret? Because TensorFlow still generates black box models.
Okay, so the question was how can we evaluate that the model that we built was the most accurate one? And we have a lot of resources on the TensorFlow blog, on the Google Cloud blog about different models that you can choose from and how you can evaluate them. One great way to do that is with Tensorboard, which I didn't show. But Tensorboard lets you, is a tool for visualizing how your model is performing, and you can look at each of the different nodes of how your model graph is actually defined. So if you want to get a little bit more detail on what each layer in your model looks like and how your model is computing the inputs and how it's flowing throughout the layers, Tensorboard is a great way to do that. There's a bunch of resources on Tensorboard out there. So yeah, I'm happy to follow up with you after and share some resources on doing that. Mm-hmm.
Any more questions?
Yes.
Like, what about false prevention, or like people now with machine learning, they can understand how to sell stuff, like example of wine, what to put in wine description.
Mm-hmm.
So people think it's like more expensive, fat benefits, not for cheating. Maybe like some ethical aspects of that. So what do you think and Google? So like you provide the tool and that's it. We also think somehow on ethical aspects of using machine learning, because it can be quite dangerous in some cases. I don't know how to behave as a human, like haircut with reservation. You show like and then using machine learning you can do false transactions and behave as a human. In internet banking and that kind of things. So what to do with that?
Okay, so the question is about how to make sure you're using machine learning for good.
Yeah, in short, yes.
Okay, so that's definitely a big topic. My goal, obviously, is to show how you can build machine learning models, inspire all of you to build your own tools with machine learning. Obviously, people can build models that aren't for the best purpose. We don't have so much control over that. But yeah, that's a tough question. Don't know the best way to answer it. But one thing that's important is making sure that your training data isn't biased. So you want to make sure that the way that you went about collecting your data represents the entire population that's going to be generating predictions from your model. That's one thing we see a lot when people are evaluating, why their model didn't perform as well as they had hoped in production. Maybe the demographics of people that collected the data wasn't representative of the people that were the end users who were using it. So one thing to be aware of is like bias in machine learning data. So there are a bunch of resources online about that. But yeah, I'm happy to chat with you after more about making sure we're using machine learning for good. Good question. Yes.
General question about machine learning.
Mm-hmm.
How much, in your opinion, machine learning is about like sorcery and trial and error, and how much it's like learned systematically and science?
The question was, how much is machine learning trial and error versus more of a systematic science? I would say it definitely more skews towards trial and error. The hardest thing that I always find when I'm starting a machine learning problem is getting the training data and pre-processing it. Surprisingly, like I wouldn't have expected that when I was first getting into machine learning, but from what I found, getting the data is the hardest problem. And once you have the data, sometimes it's tricky to pre-process it and get it into the exact format you're using. But another thing with trial and error is a lot of the numbers we saw in my model were what's called hyperparameters, things like the size of the vocabulary, the number of epochs you want to run training for. Things like that do involve a lot of trial and error.
So that's one problem with machine learning. For example, in medicine,
Mm-hmm.
how do you prove that answer is correct one? You get some kind of number vector probabilities that you have answer is this, but can you really decide is it true, and do you base your medical decisions on it?
Right. Yeah. Hyperparameter tuning is a tricky part of machine learning. We offer, I didn't talk about today, we have a tool called Cloud Machine Learning Engine, which lets you train and serve your TensorFlow models on Google Cloud Platform. So it's essentially a managed service for TensorFlow. And there are some tools there to help you tune your hyperparameters in your model. Didn't have time to get into that today, though. Yes.
So what about machine learning for machine learning? So just say, that's my data, I don't know what it's all about, like just give me
that's a good question. What about machine learning for machine learning is the question. We introduced a product in January called AutoML Vision. Let me know if this answers your question. So AutoML Vision lets you provide labeled training images to this tool called AutoML Vision. It's essentially a UI. And then what it does is you just click train. It trains a model for you and gives you access to an API for generating predictions. So you don't have to write any of the model code. All you need to do is get your data pre-processed and uploaded to the cloud. So Vision was the first AutoML product that we announced. We're working on more, but Vision is what we got right now. It's currently in alpha. If you're interested in it, you need to be whitelisted to use it, but come chat with me after. If you've got a use case, I can help get you access. That kind of fills the gap of the APIs on one side, which are targeted towards application developers, but they don't let you do anything super custom. So if you want to build any specific models that are trained on your own data, you can't do that with the APIs. On the other side, TensorFlow lets you build custom models using your own data, but does require a bit of a learning curve and a lot of data to get started. With AutoML, you need only a minimum of 10 images per label to start training a model.
Last couple questions.
Yes.
Yeah.
It's more of a business question. When you have trained the model and you're satisfied with it, how can you use it in a business scenario?
The question was, after you've trained a model and you're happy with it, how can you use it in a business scenario? That's a great question. So once you've trained your model, what you want to do is you need to find a way to generate predictions at scale, which is also known as serving. So there's many different ways to do that. As I mentioned before, we have a tool called Cloud Machine Learning Engine, which you can take your trained model, you can deploy it on Google Cloud, and then you get access to an API for generating predictions against it. So the great thing about that is you can have the application developers on one side that are just calling this machine learning engine API. If you are building that machine learning model, you can iterate on it, deploy new versions. All the application developer needs to change is the version number in the API request. So that's one way you can serve a model. There's other tools. TensorFlow has TensorFlow serving, which is a way to export your models for serving. So there's many different ways to serve it once you've got it trained. But that's a great question, because the most important part once you train a model is generating predictions on it. Yes?
So you have shown us an example of supervised learning, but is it possible to use TensorFlow for unsupervised learning?
Yes, the question was, is it possible to use TensorFlow for unsupervised learning? I haven't done that too much myself. One of my colleagues has a great talk on it from Google I/O. It's called Reinforcement Learning with TensorFlow. If you search that on YouTube, you should find it. His name is Martin. It's an awesome talk. Definitely check it out.
That's all for the questions. I believe you can catch up with Sara in private session after the talk during this coffee break or snack break that we're having. Thank you so much, Sara.
Thanks for having me.